Welcome to the Alcorn McBride Academy, a series of online courses where you can learn all about our products and how to use them for some really cool applications. My name is Scott Harkless, and today I will be your spiritual guide to the universe, the DMX universe. This course is all about lighting control. We're going to learn how to use the Alcorn McBride V16X, V4X, and Ride Player to control lighting fixtures using the DMX lighting protocol. We'll cover topics like how to interface these devices to DMX, how to name DMX channels, and how to change DMX values within our show control environment. Later in the course, we'll even learn how to easily create touch panel interfaces to control and monitor lighting levels. DMX, sometimes referred to as DMX 512, is the most common control interface for commercial lighting systems in the entertainment industry. It's such a common acronym that nobody remembers what it means, but it actually stands for Digital Multiplex, or DMX for short. DMX is nothing more than a data signal that originates from a lighting controller and is distributed to many different types of lighting fixtures and other entertainment devices like fog machines, dimmers, media servers, and so on. Whether you realize it or not, if you've ever seen a rock concert, theme park attraction, a museum, a fountain show, or even a commercial building, you've seen DMX in action. At the most basic level, DMX is a serial data stream that's transmitting an array of 512 bite-sized values repeatedly at a rate of up to 40 times per second. Electrically, this is done over a balanced 3-pin or 5-pin XLR cable using the RS-422 or RS-485 serial standards. That's the techie overview anyway. The industry tends to use some different terms for these concepts, so let's cover some of those. First, the 512-byte array I mentioned is referred to as a DMX universe. Instead of bytes, though, we refer to each element in the array as a channel. Since they are bytes, each channel has a value that ranges between 0 to 255. However, most lighting systems visualize this as a 0 to 100% value, where 0% is a value of 0, 100% is a value of 255, 50% is a value of 128, and you get the idea. The rate in which the 512 channel values of the DMX universe are repeated is referred to as the refresh rate. The maximum rate supported by the DMX standard is 40 Hz, or 40 refreshes per second. On the control side, a lighting console can be configured to associate physical controls, like faders, with a channel value. If you move the fader down, the value of its channel decreases as low as 0%. If you move the fader up, it increases as high as 100%. The DMX signal is then transmitted over an XLR cable and connected to a DMX-capable lighting fixture. Another XLR cable is used to connect that fixture to the next fixture, then the next, etc. In other words, the DMX control signal is daisy-chained to multiple fixtures in the venue. Every lighting fixture wired to the DMX universe can see all 512 values, but they need to know what channels apply to them. For this, we need to configure the lighting fixture to tune in to a specific set of channels. For example, a simple lighting fixture that does nothing more than dim a single light between 0 to 100% might only require a single channel of DMX data. Using a button or display interface, dip switches, rotary encoders, or several other means, we set the address of the lighting fixture. In this example, if we wanted DMX channel number 1 to control the brightness of our single light, we would set the address of the fixture to a value of 1. We'll talk about this more later in the course, but just know that each lighting fixture is different. Some only require a single channel, some 5, some 100. It just depends on what kind of device you're working with and how many points of control it supports. This concept is sometimes referred to as a light fixture's personality. No matter what though, every fixture always has a way to set an address that represents the lowest numbered control channel for that fixture.